Okay, this is A2Further notes. We're in chapter 6, differential equations, and this is our final example looking at second order differential equations. So solve the following differential equation: d2y by dx squared minus 7dy by dx plus 10y equals 40x plus 2. And then we're given our conditions here, so we should be able to find out then any constants. So first of all, we need to let this equal 0. So we're going to go d2y by dx squared minus 7 dy by dx plus 10y equals 0, and then find our AQE. So our AQE is of course then m squared minus 7m plus 10 equals 0, and that factorizes nicely for us, giving us m minus 2 upon m minus 5. So we have two real solutions. So we have m is 2 and m equals 5. That means then the first part is a e to the 2x plus b e to the 5x. By looking at the right hand side, so the bit I'm looking at is the 40x plus 2. So let's write that that's what we're doing. By observing our right hand side, we are going to try y equals px plus q. We then have dy by dx, which is p, and d2y by dx squared, which is 0. If we substitute this in then to our above equation, we're going to have 0 minus 7p. Be great if you could see that. So my p is obviously my dy by dx plus 10 upon px plus q, and I'm setting that equal to, of course, 40x plus 2. If we tidy all this up, goodness me, what are we going to get? We're going to get 10px minus 7p plus 10q equals 40x plus 2. I think it's straightforward enough. If we equate the x terms, you can see everything here, okay? Equate x terms. We've 10px equals 40x. Sorry, I shouldn't really have an x in there, but you'll forgive me. That gives me p equals 4. And if we look then at the number terms, we are going to have what, minus 7p plus 10q is 2. Minus 7p plus 10q equals to 2. That means 10q is equal to 30, because that's a minus 28 taken over to that side, and that gives me then q is 3. So that means my general solution is going to be y equals a e to the 2x plus b e to the 5x plus 4x plus 3. What do we know? We know that whenever x is 0, y is 6. X equals 0, y equals 6. So that means 6 equals a plus b. That's a 0, so it's 3. So I can rewrite that then as a plus b equals 3. We need to find then our dy by dx for the next part. So dy by dx is equal to 2a e to the 2x plus 5b e to the 5x plus 4. And we know what it says: dy, whenever x is 0, dy by dx is 13. So that means we know that 13, x is 0, gives me 2a plus 5b plus 4. So rearranging that, we can have 2a
plus 5b equals 9. So I have two simultaneous equations here that I'm going to solve. I'm not going to do it here, you can take my word for it, but it doesn't give you that A is 2 and that B is 1. I'm sure we're all within that. So that means then my particular solution and final solution then is going to be y equals, or A is 2, so it's 2e to the 2x plus 1e to the 5x plus 4x plus 3.